Have you ever looked up at the night sky and wondered about the significance of those twinkling dots of light we call stars? Stars are not just beautiful luminous specks decorating the celestial canvas. They are the beating heart of the cosmos, the celestial beacons guiding our understanding of the universe. Enthralling and inspiring humanity for eons, these self-luminous balls of plasma held together by their own gravity have been the subject of countless tales, myths, and scientific discoveries. Born from the chaos within dense molecular clouds, stars are the result of gravitational instability that triggers the formation of stellar nurseries. Over millions of years, this gravitational collapse raises the core temperature, sparking the process of nuclear fusion, converting hydrogen into helium, and releasing a tremendous amount of energy, which we perceive as the beautiful starlight. But stars are not monolithic. They come in a dazzling array of sizes, colors, and temperatures. From the colossal, brilliant blue giants to the petite, cooler red dwarfs, the characteristics of a star depend largely on its mass and stage of evolution. As time passes, stars follow distinct life cycles, evolving from protostars to main-sequence stars, and eventually meeting their end as white dwarfs, neutron stars, or even the enigmatic black holes. Yet stars are more than just cosmic light bulbs. They are the universe's very own alchemists. The fusion processes within their cores synthesize heavier elements, which are later spewed into space during stellar death, providing the raw materials for the formation of planets, asteroids, and comets. Beyond their astrophysical role, stars have long been cultural and navigational cornerstones. They've guided travelers, served as symbols in various mythologies, and inspired countless works of art and literature. Their study through telescopes, both terrestrial and space-based, has been instrumental in unraveling the secrets of the cosmos, from star formation to their eventual demise. So stars are not just beautiful to look at, they are fundamental to our understanding of the universe and our place within it. As we continue to explore the cosmos, stars remain pivotal, their twinkling light a testament to the vastness and wonder of the universe we inhabit. But how do these celestial beacons come into existence, you might wonder? Well, the birth of a star is a captivating tale of cosmic proportions, a journey that begins deep within dense molecular clouds. These clouds, composed primarily of hydrogen gas and dust, are the cradles of stars, their immense density and gravitational instability setting the stage for a process known as gravitational collapse. As gravity pulls the molecules within these clouds together, regions of higher density begin to form. These areas, referred to as stellar nurseries, are where protostars, the embryonic stages of stars, are birthed. The intense gravitational pull at the heart of these nurseries compacts the gas and dust, causing the core to heat up. This heat and pressure build over millions of years, the core temperature rising steadily. Now here's where things get really interesting. When the core temperature reaches a staggering 10 million degrees, a process known as nuclear fusion begins. This is the heart of a star's power, the furnace that fuels its radiance. In the simplest terms, nuclear fusion is the conversion of hydrogen into helium. This process releases an immense amount of energy, which counteracts the inward pull of gravity, creating a balance that allows the star to maintain its shape. The energy produced during fusion is immense, radiating outward from the core, making its way to the star's surface and finally being released into space as light and heat. And voila, the star begins to shine, its light traveling across the vast cosmos, bringing a bit of its warmth to the cold void of space. Each star we see in the night sky has undergone this incredible journey, born from the dust and gas of molecular clouds, nurtured in stellar nurseries, and ignited by the power of nuclear fusion. So, the birth of a star is a cosmic event, a result of gravity and the laws of physics at play. A beautiful dance of elements and energy that illuminates the universe and gives us the celestial spectacle we marvel at every night. Stars, as we know, are not all the same. Just like snowflakes, each one is unique, possessing its own set of characteristics and traits. These celestial bodies come in a vast array of sizes, colors, and temperatures, much like a cosmic rainbow of diversity. Let's start with size. Some stars are smaller than our sun, while others are so large that they could swallow up millions of suns. The smallest stars, known as red dwarfs, are about 1/10 the mass of the sun and emit a cool red glow. On the other end of the spectrum, we have blue giants. These stars are enormous, up to 20 times the mass of the sun, and shine with an intense blue light. Next, we have color, which is a direct result of a star's temperature. Our sun, for instance, radiates a warm yellow light because its surface temperature is about 10,000 degrees Fahrenheit. Red stars, on the other hand, are cooler, with temperatures around 5,000 degrees Fahrenheit. Blue stars are the hottest, with surface temperatures reaching up to 50,000 degrees Fahrenheit. Lastly, let's consider the stage of evolution. Stars are born, they live, and they die, much like living beings. They begin as clouds of dust and gas, evolve into main sequence stars like our sun, and eventually end their lives as white dwarfs, neutron stars, or black holes. Each stage of a star's life cycle influences its characteristics, from its size and temperature to its color and luminosity. But let's not forget that these characteristics are not static. They change as a star ages and evolves. A star's mass, for example, will decrease over time due to the loss of material through stellar winds and radiation. Similarly, a star's color and temperature will change as it exhausts its nuclear fuel and evolves into a red giant or a white dwarf. Thus, each star is unique, with its own set of characteristics and life cycle. These celestial wonders are not only beautiful to behold, but they also serve as cosmic laboratories, helping us understand the laws of physics and the workings of the universe. Just like living organisms, stars also have a life cycle. This cycle begins with a humble beginning in the dense regions of interstellar molecular clouds, where a star is born as a protostar. A protostar is a large mass that forms by contraction out of the gas of a giant molecular cloud in the interstellar medium. The protostellar phase is the earliest one in the process of stellar evolution. For a one solar mass star, it lasts about 1 million years. The protostar phase continues until the core temperature heats up to a point where nuclear fusion can start. When the protostar becomes hot enough to ignite hydrogen fusion in its core, it reaches the main sequence phase, the longest stage in a star's life. This is when a star is in its prime, shining brightly by fusing hydrogen atoms to form helium. As a star exhausts its hydrogen fuel, it leaves the main sequence stage and expands into a red giant if it's a small to medium-sized star, or a red supergiant if it's a massive star. This phase marks the star's transition towards the end of its life. Eventually, the star's fate is determined by its mass. Small to medium-sized stars like our sun shed their outer layers and leave behind a hot core, becoming white dwarfs. These stars fade away slowly over billions of years. On the other hand, massive stars end their lives in a spectacular explosion called a supernova, leaving behind a neutron star or, if massive enough, collapsing to form a black hole. These celestial objects are some of the most mysterious and intriguing phenomena in our universe. The life cycle of stars is a fascinating process, revealing the intricate workings of our universe. From their birth in celestial nurseries to their transformation into white dwarfs, neutron stars, or black holes, each stage of a star's life contributes vital elements and energy to the cosmos. The life of a star is a cosmic journey from birth to death, with each stage playing a crucial role in the universe's evolution. This cycle of stellar birth, life, and death is an ongoing process, continually shaping and transforming the cosmos we live in. Studying stars is a fundamental part of astronomy. These celestial beacons not only light up our night sky, but they also serve as cosmic laboratories, providing us with invaluable information about the universe's past, present, and future. One of the most important tools in star study is the telescope. Ground-based telescopes have been instrumental in our understanding of the cosmos. They allow us to observe stars in detail, revealing their colors, brightness, and even their movements. But even the most powerful ground-based telescopes have limitations, primarily due to Earth's atmospheric interference. This is where space-based telescopes step into the limelight. Unhindered by atmospheric distortion, they offer a clear and unobstructed view of the cosmos. The Hubble Space Telescope, launched in 1990, is one such marvel of technology. It has captured some of the most breathtaking images of our universe, observing distant stars, nebulae, and galaxies in unprecedented detail. But the exploration doesn't stop there. The James Webb Space Telescope, a successor to Hubble, is set to take our understanding of the cosmos to new heights. This state-of-the-art instrument will peer back in time, observing the universe as it was over 13 billion years ago. Its primary mission is to study every phase in the history of our universe, from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth. These telescopes are not just tools. They are our eyes into the cosmos, unveiling the secrets of stars, and in turn, the mysteries of our universe. Our journey of studying stars is ongoing, constantly revealing new insights and expanding our understanding of the universe. As we delve deeper into the cosmos, each star we study brings us one step closer to unraveling the grand tapestry of the universe, reminding us that we are all made of star stuff, forever bound to the cosmos by the light of these celestial beacons.